Earth has a mass of 5.98 times 10 to the 24th kilograms. The average mass of the atoms that make up the Earth is 40 daltons. How many atoms are there in Earth? All right, so this problem might seem difficult, but if you know how to think about this in the right way, then it's actually very easy. And it's partially due to the fact that both of the values we're given, the mass of Earth and the mass of the atoms, they're both in mass. They're both the same dimension. And that actually makes our job easier, especially since we're only looking for a number here. Because if you think about the problem like this, we have the mass of the big thing here, and we're given the mass of each of the small things that make it up. So if you think about it in a way, basically what that means is if we were to take the mass of the small thing and multiply it by the right number, that's going to give us the total mass of the Earth here, because that's what we're adding up. So what that means is that if the mass of the Earth, I'm going to write that as m sub e, is going to be equal to the mass of the atoms on average, I'll just write that as small m, multiplied by whatever that number is. So I'll define that as the variable n for the number of atoms. So if you think about it, that makes a lot of intuitive sense, because if we have a bunch of the small masses and multiply it by that number, it's going to add up to the mass of the Earth. Or, since we want to find that number, then some very basic algebra will tell us that the number of atoms in the Earth is simply going to be equal to the mass of the Earth divided by the mass of those atoms. So, very easy algebra. We already have the equation we need. All that's left is to plug and chug and also do some unit conversion. So that means that the number is going to be equal to the mass of the Earth, which is given to us as 5.98 times 10 to the 24th kilograms. Divided by the mass of each of those atoms. So that's going to be 40 daltons. And let's do a conversion. If you're using a textbook here, then Appendix D will tell you that 1 dalton is equal to about 1.661 times 10 to the negative 27th of kilograms. So let's do a very brief little unit conversion here. And say we'll multiply that by 1.661 times 10 to the negative 27th. And let's cancel out that u there. So that's in kilograms divided by the dalton right there. So let's multiply it by this whole thing, and we get a final answer of 9.0 times 10 to the power of 49 atoms. So roughly, this is how many atoms there are in the Earth, according to these approximations that we're making here.